Okay, before you get started on this week's stuff, let's try a warm-up. That'll let you know how you're doing. So match the following phrase on the left to the probability that describes it. So your choices on the left are a certain event, an impossible event, a very likely event, an unlikely event, and 50% chance. And then your choices on the right, 1 over 1,000, 999 over 1,000, 0, 1/2, and 1. So take a minute before you look at the next slide for the answers. All right, did you get them right? So a certain event has a probability of 1. An impossible event would have a probability of 0. A very likely event would be almost 1, but not quite. So 999 over 1,000. An unlikely event, 1 in 1,000. And a 50% chance is 1/2. I hope you got all those right. Let's try one more. So draw a tree diagram for drawing 2 slips of paper, one at a time, from a bag containing slips of paper that have the letters MAD on them. So this is without replacements. Label the probabilities and all possible outcomes. So, in other words, you have a bag. There are 3 slips of paper in it. On one of the slips, it has an M. On another slip, it has an A. On another slip, it has a D. You're going to pull out one slip. You're going to record what it has, and you are not putting it back in the bag. So think about all that vocabulary that we talked about last week: independent, dependent, and then how you draw a tree diagram. So draw your tree diagram, label all the probabilities and the outcomes, and make sure you list the total outcomes on the far right. When you're done, go ahead and go to the next slide. Is that what you got? So notice your first slip, there are 3 pieces of paper in the bag. All are equally likely to get chosen, so your probability is 1 out of 3 for each, the M, the A, and the D. The second slip, however, now there's only 2 slips of paper in the bag, so you have a 1 out of 2 chance for either of the other letters. Notice I didn't put a branch right here that would say an M, because there's no M in the bag. So if you accidentally made a branch that had an M on it right there, as long as you put the probability was 0, you're okay, because it's an impossible event to get an MM. The only way it would be possible to get an MM is if this was with replacement instead of without replacement. Okay, I hope that was a nice refresher for you. Remember, here these should sum to 1. And then on each set of little branches, it should sum to 1. And then all these separate outcomes should totally sum to 1. All right. Good job.